So what are equilibria? It's been observed that some reactions never go to completion. There are reactants left over no matter how long you wait. This occurs when conditions are present allowing the forward and the reverse reactions to occur simultaneously at the same speed. So the amounts of products and reactants stay constant over time. When this happens, the system is described as achieving equilibrium, and its chemical equation includes a double-headed arrow. This does not mean that the amount of reactants and products is the same, or that the forward and the reverse reactions are equally spontaneous. The following conditions are required for a system to be at equilibrium. Number 1, there is a dynamic change at the molecular level, but not at the macroscopic level. In an equilibrium, the individual particles change from reactants to products, then back, but it looks like nothing's happening because there's no net change in particles. This means there will be no color, pressure, concentration, or pH changes observed. Number 2, equilibrium can only be achieved in a closed system. This means that there can be no input or escape of any component, including energy. And number 3, equilibrium can be approached from either direction. This means that you can start with either all reactants or products and reach the same final concentrations. Water in a closed container is an example of a physical equilibrium and is represented by this equation below. The evaporated water gets trapped in the container. Soon the air space gets saturated and can't hold any more water vapor. This is when your system has hit equilibrium. Some of the water vapor will hit the surface of the liquid and rejoin, allowing space for other liquid molecules to change into gas. However, the amount of particles in each state never changes, as long as conditions stay constant. So it looks like nothing's happening, even though the individual particles go from being a liquid to being a gas, to going back to a liquid, to being a gas, and for every one particle that moves to the right, another particle moves to the left. Watch the animation. It has a really fantastic example and analogy for equilibriums.